This is Mr. Beck Does Your Homework. This is AP Physics, Homework 2.5, questions 10 and 11. It says, instructions for finding a buried treasure include the following. Go 502.1 paces at 197 degrees, turn to 259 and walk 133 paces, then travel 91 paces at 266 degrees. Find the magnitude of the resultant displacement from the starting point. What we have here is three vectors, so we've got to keep track of where they are, because this is going to be 0, this is 90 degrees, this is 180, this is 270, and this is 0 degrees. So let's see, 502 paces at 197, so that's 180. So my first step is going to be this way somewhere for 502 paces. Then turn to 259. Well, 270 is straight down, so 259 is going to be somewhere around here. So I'm going to go 259 and walk 133 paces, so that would be something like this. And then travel 91 paces at 266. Well, that's a little bit more, 259, 266, so that one's also down here, and that's, for me, 91 paces, so that's a small vector here. So I've got these three vectors, and if I head to tail them, I know that was my first vector, then my second one is a little bit over this way, and my third one is a little bit over this way, and so what I'm resulting with is a final vector that goes down in this direction. How in the world am I going to do this? Well, what I've got to do is add my x's, 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 and then add my y's, 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 and then that'll get me my final position. So I've really got three little right triangles here. So I'm going to take each one of these and split them into the components. Now, what about this 197 degrees? We've only been dealing with like acute angles here. So I've got two choices here. I could either figure out what this angle is from 197, and that'd be 180, 197, so that's 17-degree angle here. But instead, actually I could do that for all three. Instead, I'm just going to plug 197 into my equations, because that will automatically give me the positives and negatives I'm looking for. What I should wind up with is negative x, negative y, and negative x, negative y, negative x, negative y, because all three of mine are in this quadrant. So let's look at vector 1. I've got 502.1 paces at 197 degrees. So my x is going to be 502.1. Remember, x, if I'm measuring my angles from positive, is 0. So if I'm measuring from here, which all of them are, I know that I can just plug it right into my x's cosine and y's sine. So this would be 502.1 times the cosine of 197. And watch, when you enter that in, how this is going to just be a negative value, and you take it as what it is. So it's going to be negative some amount. So that's my first one. My second one, x2, is going to be, let's see, 133 paces at 259. So I got 133 at 259. So x2 is going to be 133 cosine 259. Well, I've also got my third one is going to be 91 at 266. So x3 is going to be 91 cosine 266. So that'll give me an x2, and that'll give me an x3. So my total x is just going to be this, which is negative, this one, which is negative, and this one, which is negative. So it's negative, more negative, more negative, so one big number. So I will get my x total equal to some big negative number, just telling me that it's down. I'll do the same thing with the y's. So my y1 is going to be 502.1 times the sine of 197. And you should also see that that's going to give you a negative, some value. My y2 is going to be 133 times the sine of 259. And y2 is going to give me a negative value. And my y3, my third y component, is going to be 91 sine 266. So y3 is going to give me some negative value, because they're all pointing down. And then I'll get a y total equal to negative something or other. Now, if I want the magnitude of the resulting displacement, now I've got an x and a y. So now what I'm going to do is use the Pythagorean theorem, or as I like to say, Pythagorize. A squared plus b squared equals c squared. A squared could be my x, b squared could be my y, c is my resulting, so square root that, and I'll get a c equals. And that will be my answer for my magnitude of the resulting displacement. That's going to be a positive number. Now it asks for the angle. So now I have to look at it, and it says, you know, between negative 180 and positive 180. So what it's doing is it's measuring angles around this way up to 180 as positive, and angles around this way as negative. So when I draw this final triangle with my y and my x, I'm going to draw my y, and I'm going to draw my x, and I'm going to get myself this triangle. So it's going to want the angle, and I'm going to have 90 plus whatever this is. So this one is 90, and then whatever this is. So now again, I can use a tangent function. So I can say that the tangent of theta is going to be x over y in this case, because I want this angle as my opposite over my adjacent. So theta is going to be the angle whose tangent is x over y. When I solve for that theta, I'm going to have to take that and add 90 degrees to it, and then take the whole thingamahoo and make it negative because it's around this way from the axis instead of around this way. So a little bit complicated, but listen to this one again, go slow, and you'll see exactly what I'm talking about.